I'd like to go ahead and welcome everyone to our virtual trade talk. My name is Sarah Hague. I'm the Executive Director here with the Electrical Association of Philadelphia. We've got a lot of familiar names, a lot of new names. So thanks so much for spending some time with us today. This afternoon, I am, of course, joined by my colleague, Matt Divert. He's our program manager, and our speakers. We've got Mary Ann O'Connor and Jeff Smith from Staco Energy Products. And of course, we have our buddy Scott Stilley from member company eSite Systems. Welcome and thanks everyone for joining us. And before we get started and turn it over to Scott, I do want to make sure everyone's aware, of course, you know that we cannot see or hear you. And of course, we are recording this webinar. So that does not mean, however, we don't want questions. Go ahead and use the chat feature. We'll try our best to either answer the questions during the event, or certainly we will field questions towards the end. So with that, it's my pleasure to turn it over to Scott with eSite Systems. Thanks, Scott.
Thank you, Sarah, and thank you, Matt. Hello, my name is Scott Stilley from eSite Systems. And today we're going to talk about a product that I have. We're a traditional manufacturer's rep firm, and we're going to talk about Staco. Introduced was Mary Ann O'Connor. She's an electrical engineer, been in the power industry for 25 years, has worked at Eaton with Staco for 4 years as a Northeast Regional Manager and Sales Director. And we also have Jeffrey Smith, three-phase product manager at Staco. He has been in the power quality industry for 36 years. Uninterrupted power systems, power distribution units, batteries, from 10 to 4,000 kVA systems installed in service throughout his career. I have been in this industry for over 20 years and do a lot of design with engineering and next slide, please. Design with engineering and customers and end users. So today's topic is going to be power quality market trends. Mary Ann's going to come after me, and then it's going to be Jeffrey. Next. So a lot of times I get asked, who is Staco? And we're a lot more than just UPS. We are harmonic mitigation, emergency lighting, power factor correction, variable transformer sets, and power quality load studies, frequency converters. We have a wide range of products that we serve. Next. And these are some of our customers. And you might see Schneider Electric in there, and you might say, oh, that's a competitor. But it's not. They use some of our test sets. We have Tesla, GM, Ohio State, Johnson & Johnson, Amazon, to name a few of our customers. Next. I'm going to now turn it over to Mary Ann, and she's going to go through the power quality industry trends. Unmute, Mary Ann.
Yes. Thank you, Scott. I appreciate that. Welcome, everybody. Thank you for attending. We really appreciate it. I'm just going to cover a few of the trends that are out there, and then I'll be handing off to Jeffrey. So next slide. So wanted to address some of what's going on in the emergency lighting industry. As Scott said, Staco is a manufacturer of emergency lighting, single and three phase, and it's probably one of our biggest growth sectors. And we are doing a lot in that industry. So we're seeing that in the emergency lighting industry, with the increase of LED lighting, there's lesser demands, so the loads are less that are required. So the lighting inverters are a lower kW rating. And when we go with centralized lighting inverters, you are really decreasing the maintenance that's required on applications where, let's say, you're replacing batteries, or you're having small microinverters that you have to check up on. So, and all of our lighting inverters do fast transfer, so there's no lag that causes a bulb to kind of dim and then take some time to come back to full light. Also, one of the trends that we're seeing out there, because the LED lighting is decreasing the power demands, there's an increase in the microinverters in that 250 to 1 kW range. and they can be used for multiple lamp and fixture types. And it decreases the cost on the maintenance, increases the efficiency and the time it takes to change out battery packs. And you can use these microinverters on all existing lighting. And what's nice too is depending on where it is, you can keep the design aesthetic. So that's very important. And again, because of these lower loads, we're either going with smaller units or the units are able to back up more lighting fixtures. So there's a decrease in the lighting inverter rating. So a smaller demand load in that, and we're seeing in that 3.5 to 7.5 kW range. And we're seeing a lot of that in segmented areas, let's say in a co-location where they want to segment out the backup on the lights. And a very big trend that we're also seeing is an increase in PoE, power over Ethernet, for smart buildings. So you can kind of control your lighting from source to illumination, and you have a lot of control and management over it. The PoE, we're seeing it pop up in different areas. I'm seeing it pop up in New Jersey. There's a lot of talk about it in New York City, but it is kind of expensive to implement it. But once it's implemented, the ROI is very good, and you also have a lot of control on your infrastructure. So we're seeing a lot of installations of PoE in New Jersey and Texas, and on the West Coast. So next slide. So with lighting inverters, there's centralized and distributed. Staco does centralized lighting inverters. It uses the existing power infrastructure. It is easier to maintain and take care of equipment. It does require a little bit more cabling, and there is some distance limitations that you need to take into consideration. And on the larger PoE switches, it's a little less cost effective. It's a little bit more cost effective on the smaller ones. So with you also have distributed advantages. So on the distributed, that's where the lighting inverter is accommodating that particular light fixture. So there is less cabling. Distance isn't as much of a problem, but the maintenance is more. So you're replacing battery packs, you're checking more points. So that takes more time. It costs more, and you also need to be conscious of some of the infrastructure needs in the ceiling that for powering that. Next slide. There's different types of bulbs out there. We all know incandescent. LED lighting is certainly most of what we see, but there's halogen and fluorescent, and all of our lighting inverters can take care of all of those bulbs, those types of bulbs. And you just need to make sure that the transfer time is fast enough so that any bulb that does dim doesn't take some time to come back once power is coming back to the light. So very important to look at the transfer time of the emergency lighting and not have any lags. And the Staco lighting inverters do handle all of those kinds of bulbs. Next slide. With lighting inverters, there's online and offline. So offline is where the load is powered directly from the grid. So once a failure is detected, it switches over to the lighting inverter. The online is the lighting inverter is always powering the load. So you have the power come in, it takes AC, converts it to DC. The DC charges the battery, goes from DC back to AC, and then you get a pure sine wave out to the load. So it's very conditioned, and the power is kind of cleaned up. So when power does go out, it's a very fast transfer. You don't have to wait for that inverter to come on because it's always on, because it's a double online conversion. So it kicks in immediately. And so the online lighting inverter definitely is an advantage as far as getting a pure sine wave out to your load, having power conditioned, and not having any lags when the power goes out and you need to switch over to battery. So next slide. What dictates the emergency lighting is the UL 924 rating. with the UL 924, what you do is you take the battery and the UPS and we get it certified for 90 minutes of runtime. And so some options or some opportunities or applications call for a longer runtime or shorter runtime. So there's auxiliary lighting, and what we can do is we can change the battery out and provide that longer runtime or shorter runtime, and still remain and keep and maintain the features required by the NFPA, so the fire agency. We also have, and we can accommodate that with our oust units. So you have an application and you need 4 hours runtime, but you still need that life safety feature. We can definitely provide that. Next slide. When you're doing emergency lighting design, there's a lot of design considerations that you need to take into account. So let's say points of emphasis. Those are mandatory points of emphasis. So doors, stairs, are there changes in floor levels? Are you near fire equipment? So you're looking at what is your lighting requirements, what are your loads, and where does the lighting have to be? For example, if you're having an exit sign, what is the viewing distance? Is it sufficiently illuminated? You have to look and say, hey, we have an escape route. What is that escape route? And how much does the lighting have to be illuminated there? Then there's non-essential areas like elevators or escalators or bathrooms. And that has to be taken into consideration. And then you have larger areas where, let's say, you need a little bit more lighting and it's a pass-through on an escape route. And then there's other areas where they're like production lines or a plant floor that you need to look at. And those are kind of high-risk task areas that you need to say, hey, how much lighting do we need to have here? And you want to take a complete look at all of that and see what your power requirements are, and then determine what it is from there, and make sure that you have the backup power to make sure that those lights go on when they're needed in an emergency situation. Next slide. I like to put up the lighting codes because I think it's important. For the UPS, we do it to the UL 924, which is the 90 minutes runtime requirement. And then you also have the National Fire Protection Life Safety Code. So like the NFPA 101 looks at the minimum illumination that needs to be provided. Then you have something like the NFPA 99, which is for healthcare facilities. So those are kind of tighter controls that you need to look at. But these are just some of the pertinent codes that you'll see in those kind of emergency lighting environments and requirements. Next slide. UL 924 for PoE, Power over Ethernet, where I talked about that a little bit earlier, but we're definitely seeing an increase of application on that. And basically it refers to one Ethernet cable to power the light fixtures and transmit data. So basically from source to illumination, you have the backup through the centralized lighting inverter, and the Ethernet is power over Ethernet. So you're able to control and manage your software and all of your items on that line. So it's lighting, sensors, HVAC, security cameras, Wi-Fi, all of that is controlled on that. So you have better control over your building. You have higher reliability, better efficiency, and the PoE lighting tends to be higher for an installation, but the long-term benefits for control and ROI and flexibility definitely pays off. So we're definitely seeing that trend and more talk about it. And I think in the not too distant future, we'll definitely be seeing more of PoE installations. Next slide. Again, the digital building, it's really important because you basically will have a smart building. So it's all converged on a digital network. You're controlling your HVAC, your security, your lighting. And all of these data points are very important to the building owner. You can start to determine and control, let's say, your lighting. If somebody isn't using a conference room, the lights go off. If somebody's going in, well, the lights go on. If there's nobody in the conference room, you control the temperature that way. So they can do this live, and they can manage their building that way. So they're decreasing their energy usage. It's more cost effective to run. They have more control. And with all the stuff that's going on now with data analytics, they can keep getting data points on this, and it helps them to make the building more efficient and save money and increase efficiency. So it's definitely something, I think, a wave of what's coming up, especially with the newer buildings going up. Next slide. For Staco, we have single and three-phase lighting inverters. On the single-phase line, we have different frame sizes. So we have a small that goes up to 3 kW, and then we have a large frame that goes up to 10 kW. If there's anything higher than that, we parallel some of the larger frames together. I will say mostly with what I see, 85% of what we're doing is under 10 kW. And then we do have an ultra light frame, which is small, that can be wall mounted for some very small environments. So next slide. For the three-phase lighting inverters, we offer two different types. One covers from about 9 kW up to 54 kW, and it's a native 12208 volt. It's a very compact design. And of course, if there is a 480 volt 277 requirement, we can just install transformers to take care of that. So next slide. And our P three-phase UL 924 kind of goes from 58 kW up to 225 kW. So when you look at the scope of the lighting inverters that we have, both single and three-phase, there's very little, there's just a broad offering there. So there's very, very few opportunities that we can't accommodate. Next slide. As far as lighting inverters, all kinds of applications. We do a lot with co-locations, hospitals, commercial buildings. There's also the elevator backup that Jeffrey's going to talk about, but conference centers, casinos, and when we've done emergency egress lighting and ventilation for the SR99 tunnel in Seattle. And all of the Sephora retail stores have our lighting inverter in there. So wherever there's lighting that needs to be backed up in a time of emergency, we've dealt with those applications and can accommodate that. Next slide. We also get a lot of requests for the UL 924 to be in like a containerized solution, an NEMA 3R or 4X, because they want to put outside the building. So we can definitely do that. I would say about 30 to 35% of our applications call for some kind of customization or value engineering, and that's something that Staco embraces. Our engineers love it. And we're also seeing an increase of applications for renewable energy applications, where we do a lot of containerized solutions that require value engineering and different heating and cooling based on where the location is. So we do battery backup for battery controls for the battery storage systems. And then we have situations where somebody needs to back up their infrastructure or their different products on their automation, or so they need that, but they don't have the physical space. So we'll take the containerized solution that we've developed, and it will come like an added part of the building. So it will be outside the building and add the protection and the added support that they need to keep their building up and going in case there's an outage. And then we also have containerized solutions for mobile use. So where somebody needs backup power or like data center capability on a site temporarily, we can provide those solutions as well. So we have standard and customized solutions to be able to meet those requirements. Next slide. Some examples that we have, we provide the UPS for the scanners at the Border Patrol, so with the border control scan. So you'll see there with the UPS, there's something on the side of it that's the air conditioner. So it will stay out there and keep powering that, and it won't go down for the border control application. Next slide. And for that border control, that was an ANEMA 4X. We also do a lot of grid solution enclosures, and those typically tend to be 3R, NEMA 3R enclosures. And we will provide the backup for solar and wind farm sites, or the controls again for the battery storage. And also for onshore and offshore, we'll take our voltage regulators or our inverter with battery banks and put that into a customized enclosure and design that for the application. And we see a lot of those applications in that 80 kVA up to 300 kVA range. So, and we have temperature control, and we'll design it. We'll work with the engineers too, with the customer, to make sure that everything is taken into consideration too, so that it's appropriate for the environment it's going into. Next slide. So from here, I'm going to hand it over to Jeffrey, and he's going to talk a little bit about some other power quality trends and how some of our other equipment addresses those issues.
Okay, thank you very much. Hope everybody's staying awake. What I'm going to talk about a little bit here are some of the power quality trends. We have voltage regulators and power conditioners. These are the systems that we're going to be talking a little bit about. Power factor correction, active harmonic filters, and then also the PPS test sets. These are systems, we'll talk a little bit about it. Next slide. Why UPS power? You have power problems that we've all seen throughout the industry. Power failures, your sags, your surges, your spikes, under voltage, brownouts, when the power comes down a little bit. The UPS system, we're able to keep the power up, and a lot of times without even going to battery in brownout situations. Over voltage situations, electrical noise getting on the lines, frequency variations. Typically, this is when you have a power outage, and in the United States, I'm talking mainly in power outage, then you go to generators. Sometimes the generators, if they're lightly loaded, they can vary a little bit with the frequency. Outside the country, we do a lot of this because we have a lot of customers out all around the world where the frequency is not very stable. Transient switching, that keeps the notching out. We're able to minimize that to the load. And then the harmonics distortion, we're able to, with the UPS systems the way it is, we're able to minimize the harmonics being fed out to the loads and the reflection back to the utility. Next slide. The renewables, increase in renewables, like Marianne was saying, the solar, wind, onshore and offshore capability, battery storage type systems, the green hydrogen, where it's carbon free, that's starting to grow, where we're going to split water into hydrogen and oxygen. Money is being invested in green hydrogen. This is something that's new for a lot of people, but they've been doing this. Hyundai is pioneering the H-fuel cell for cars, but this is something that's been going on for many years. We want to be able to reduce our coal usage, slow down on gas, for renewable sources, and a few more things here down below. Battery U.S. storage installations have topped a gigawatt, and they're expected to grow to 7.8 gigawatts in 2025. That's a lot of power. That's a lot of power. So we have an increase of 25% in residential, commercial, and industrial buildings. All right, next slide. Power quality issues that we talked about were sags, swills, flickers, harmonic distortion. Backfeed is the second biggest concern in renewable energy. We're looking at different systems out there that can help us minimize these sags, swills, and flickers because this is going to be put back onto the utility in these areas. And we want to make sure that we're not causing issues for other areas. And for the existing loads, we want to make sure that the existing loads has nice, good sine wave for the products that we're working with. Power disturbances at the company and factory can cause malfunctions. There's many times we've been in facilities where they're saying that down the street they do welding at that facility, and with the arcing that they do, it causes an anomaly on the power line, which causes issues within a different customer's facility. We're able to put in products to be able to eliminate and minimize all of these types of issues. Next slide. Harmonics. Harmonics is one of the biggest issues that we've seen in the last 20 years with new things coming out, EV chargers, computers, lifts, lighting, and it degrades the grid quality. And in order to fix that, we have to be able to make sure that we can take the power that we're feeding and then the reflection that they do back to our products, we don't reflect back to the grid. That's one of the big things that we're looking at. Harmonic filtering. You look at harmonics, and that's just electrical noise on the lines. And with these harmonics, you're getting different levels depending on the type of system that you have out there. Drives, variable frequency drives, adjustable speed drives, they can cause harmonics back onto the grid. In electric motors, harmonics reduces the useful torque and decreases the performance. Well, these are the types of things we have to look at. Heat is one of the biggest issues with harmonics because it'll overheat some of your systems. And it's like it says, this all equals loss of money, because when you're losing with harmonics, when you're losing it to heat and that type of thing, you're just wasting electricity. Next slide. Automatic voltage regulators and power conditioners. Next slide. In our Staco speak, we call it the AVR and the PPC. The AVR is a system that is with electromechanical devices, and meaning that it takes a little bit of time to change the voltage up and down depending on what the systems are. Now the PPC, it's an electronic version where if you have instant, you have changes, there's an instant change to keep the output within the regulation of what we state, plus or minus 1 to 2%. So there's different types of things that you can look at for these systems. We have AVRs that are suitable for industrial applications, and we're talking like HVAC systems, variable, the 3D printers, any of these types of systems that can really put, bring sags and surges within your facility. Power conditioners are suitable for, all kinds of equipment, medical equipment. We do a lot of this stuff, a lot of power conditioners for the oil and gas industry. They get a unit and they put the regulator on the bypass of let's say a UPS, just to make sure that it's still good quality power. Next slide. The modular power conditioning systems. This is what the AVR type systems would look like. 120 volts to 600 volts, up to 2000 kVA. We got a 1% or better continuous voltage regulation, 97 to 99% efficient, variable flexible design. We do a lot of these systems, but this is, I guess, what I would call the slower system. It could take up to 2 to 3 cycles to get your voltages back up to the level that you're looking for. Next slide. When we're going through the power conditioners, the electronic power conditioners, we're able to do this very quickly. Basically, it is a UPS system. As you can see here, it's the same what we've shown before. It's the UPS, but without batteries. And the unit is able to do this without batteries. We're able to take a higher voltage and even down to lower voltages without batteries and still keep the power up and running. We can go down to as low as 40% on the input and still keep the regulated output. Next slide. Here's some examples where we put the power conditioners in with CTs and MRIs. Depending on the area, some areas have very good power quality, but they want, air conditionings turn on, systems turn on in a hospital situation. This way it keeps the levels at the right, the voltage at the right levels. Car washes, it's amazing. I mean, we put systems in car washes to keep the flow and people going, so they're not stuck inside. Because if the voltage goes too low, the system would shut off. This way we keep it going and you get your nice clean car. Next slide. Power factor and harmonic filters. Next slide. Power factor correction. That's what it really is. What it is when you have a lot of motors, drives, that type of thing, it can affect your power factor, meaning you can have a very low power factor. Some parts of the country, they charge penalties. The utilities will charge a penalty if your power factor is less than a 0.95. Some areas, they don't worry about that. However, in certain areas of the country, the power companies don't have enough power putting out, so they're going to their large customers that use a lot of power, requesting that they put in power factor correction so they can use the full amount of power that they have and not buying power that basically is not used at all. Poor power industries, automobile manufacturing, electrical plating, hospitals, textile, mining, brewery, foundry, oil field, and even these are the types of things. Induction motors, furnaces, welding, fluorescent lighting, stamping, AC drives, VFDs. These are the types of things that are also where, you can get, the power factor can be low enough that, if you put in power factor correction, you can increase the information you get back from it. All right. Next slide, please. This is what the power factor correction that Staco offers looks like. You can see there's different steps in these sections. And what it is depending on how much kVARs we have to add in to bring your power factor up to the right levels that you're looking for, then we put in different steps, and depending on what's going on in your facility. You have motors turn on for, let's say, air conditioning. All of a sudden, your power factor goes very bad. We add in another step of the capacitors in there, and boom, it brings it right back up to where it gives you good levels. We can do it in NEMA 1 enclosures. That's our standard, but we do a lot of these systems with NEMA 3R, NEMA 12, even NEMA 4X. Next slide. So power factor and harmonic filters. Harmonic filters are, I guess what I try to tell people, just think about the noise cancellation headphones that you wear, okay? What they do is they take the sound that's out there, puts it in there, and does a 180-degree phase shift and sends it back out there, okay? Basically, the harmonic filter does the same thing. We read the harmonics that are on the line right there where we're looking at, and then we put a 180-degree signal out inducted into that system to eliminate the harmonics. We go from basically the 3rd to the 51st harmonic in these types of systems. Every one of these, as you can see, harmonics are in water treatment, petrochemical, normal facilities, data centers, plastics where they're making plastic, packaging systems, power and steel processing, where you have lots of motors and drives. This is where you're going to see a lot of these types of things. All right, next slide. This is what our harmonic filter looks like. You know, we have wall mounted and then or freestanding. Typically, it's going to be a freestanding type system. They can go from 25 amps all the way up to 1200 amps. What we do is we parallel the systems up to what we need. All right. Next slide. It's amazing. We're doing some work with Marianne in New York City, and the elevators and the cranes that are building the buildings next door, they're causing so much harmonics being fed into the facility, and their power factor was so low that we installed harmonic filter and is as required the power factor correction to adjust the power factor to give them better quality power in these facilities. Next slide. PPS test sets. Next slide. These systems here, what they do is they can take the incoming power and they're able to raise and lower it from basically 0 up to 1,000 volts. What are we doing here? Well, when you're a manufacturer of a piece of equipment and you design it, you build it, you have it ready, you ship it out to a customer, and then all of a sudden the customer says, it's not working exactly how you did. And they send it back, they look at it and go, everything looks fine. Well, the problem is they're not looking at what are the power quality areas around the different parts of the country. If somebody's voltage is low, one of our big customers, they make fryers for like for French fries for a lot of the major Wendy's, McDonald's, Burger King, all those types of things. So when they got their customer came back to them and said, you know, the fries aren't being cooked long enough, or they weren't hot enough. So they went back and they looked at it and they're going, oh, in your area, your voltage dips at different times of the day. And what it is we need to be able to test for that type of system. So they buy one of our test sets, they lower the voltage, drop it down there and said, okay, this is what we need to do to adjust it to make sure that when they get their quality product out in the field, that it cooks the fries exactly how they need it. Same thing on the other side. If it's over voltage, they want to make sure that they buck boost type of this system to where we have the right you know, power quality that gets into it. So it's amazing how power quality even gets into our food and stuff. We were talking about some of our competitors, even some of our UPS competitors, they use these types of systems to be able to test their equipment to make sure that when they say the power goes down to 340 volts and then it goes on battery, that's what actually happens, that type of thing. Next slide. Elevator backup solutions. We're doing a lot of different systems out there that are for the backup power for the elevator, like Marianne was saying. One of the big things is in California, it's a little different in California. They want to be able to, the fire department has said that we want to be able to ride the elevator up and down if we deem that everything's okay in the elevator shaft and capabilities for 2 hours. So anything greater than 4 levels, that could be 2 levels above ground, 2 levels below ground. Anything they have 4 levels, they want to have 2 hours of backup time to be able to, you know, get people out. These are mainly for residential type apartment buildings because there's more and more elderly people to where they can't walk down the stairs. I mean, if you've tried to do it, walk down some of these stairs in some of these bigger buildings, yes, this is what they're trying to do, is be able to get people out. What we're doing is we're backing up the elevator systems so it has the lighting and this information. So this is what we're looking at. So we can back up the elevator to get it up and down and to keep the lights on. Now, on the East Coast, all they're wanting it to do is to where the elevator would come down to either go up to the next level or down to the next level, open up and stop. So that way you're not trapped in an elevator. But eventually what's going to happen, as we all know, the way things have gone in the past, is it starts on the coast and it starts to creep in. And whatever, if everybody likes, the fire departments like the 2 hours, then that's what eventually the whole situation will be for that. So these are the types of things we're looking at. Next, please. Elevator applications, one of the big things we have to look at is motor loads. The reason why is because when you turn a motor on and you start to slow a motor down, what it does is it starts to act like a generator back to the UPS. So what we've done is we've come up with a system to be able to remove the regenerative power being fed back to the UPS so we don't overload the UPS and cause damage to it. We're working on load profile uses so we can look at different size systems, the types of elevators, the lift, the feet per minute. It's amazing how many different things that are all available when you start looking at different vertical markets within the industry. And then, like I said, with the emergency lighting, I know there's a lot of people out there that if the lights would go off in an elevator, it'd be pitch black in there. And that would not be a good thing. But these are the types of things that we're looking at and to make it better and quicker, better, faster type of thing. Next slide. Why use UPS for elevator applications? Smaller footprint than a generator. Typically what it is, mainly in California right now, in order to put a generator out there, you have to go through EPA testing, you have to go through all these different ramifications to be able to get the generator put in. Okay, that's one thing. Then you have to do monthly testing. Then you have to make sure you have your fuel. The biggest issue we're looking at right now is in California, you can only run the generator so much per year before you're penalized. And if there's more and more issues out there, then it's more difficult to be able to do that. Flexible to where you can, put the UPS in there for the elevators too. Typically on systems that have multiple elevators, only one elevator is deemed the emergency one and it runs it up and down. Now, if they have multiple that do that, typically at that time, there'd be 2 systems out there. And then this way you're able to go back and forth and see exactly what happened, when it happened, and it gives you a more eco-friendly type system. Next slide. The UPS systems that we offer in a 3-phase, these are my products, the 10 kVA through 60 kVA. The platform is basically a 208 volt, 120. It's a 3-phase 4-wire system as standard. Now in this configuration, we're able to put up to 2 transformers, an input and an output. Or in some cases, it could be 2 inputs if you're looking for a dual input system where you have an input transformer and a bypass transformer. We can, up to the 40 kVA size system, we can put up to 2 strings of batteries in here. And that's one of the nice things. So you get runtime, you get batteries, and you can change the voltage if you need to. Next slide. The industrial UPS, we're working on even some new systems out there for a more heavy industrial. This is a very light industrial. It's for systems to where it can go into a hotter environment. But one of the things you got to watch for the hotter environments, the unit can handle it, but it's the batteries that are usually where there's an issue on that. It is a very good thing where we can actually do a 3-phase in, single phase out. You get a lot of the industrial type systems where they have 480 in, but they want 120, or they want just 277 out. We're able to do it with this system here. Next slide. The PE series 80 through 200 kVA. This is a transformerless UPS. It's 4D in and out, 3-phase, 3-wire. There is no neutral for this. This is designed to where you can put this in a data center and or put it over to a power distribution unit that has transformers that you can step it down to your 12208. All right, next slide. The first line P, 65 kVA through 500 kVA. It's a 480 volt box, 3-phase in, 3-wire, 3-wire or 4-wire in or out. So it's very flexible, very much a workhorse of our systems that we utilize here. Next slide. Battery monitoring systems. We put in battery monitoring as required by the specifications. It's mainly for the individual batteries, so we can monitor each individual battery. If you do it right and you put the system in and you trend batteries, you can actually see them when they're going to be going bad. You do that because the weakest link of any UPS system, no matter what manufacturer you have, is the batteries. So if you can monitor the batteries and trend them and watch them, and you can actually see and then remove batteries before they actually fail. And if you do it right and get that done, you have a better system overall. Next slide. We're working with lithium batteries. Lithium batteries are it's an awesome product. It's very lightweight comparative to VRLA batteries. It has a 10-year real basic life of that. So when I'm saying a 10-year life, they give you a warranty for 10 years on it. Whereas on a VRLA, you have usually 1 to 3 years of a full life, and then the remaining part, it's prorated. So, but with the lithium, there's all kinds of new technology that's coming out there. Actually, and what it is every year it seems like there's more details, more information coming out with lithium ion batteries. All right, next. So you can see the benefit, up to 8 times lighter than installed weight compared to VRLAs, and smaller footprint compared to VRLAs. It's one of those things you can put one cabinet, fill it up full, and sometimes that's 2 and 3 cabinets of VRLA for the same amount of power. Faster recharge time, 3,500 cycles to 80% depth of discharge, 20 years float life at room temperature. So it's one of those things, if you don't ever use your system, it can last a lot longer than normal. Optimized performance for applications for high power and medium power. Next slide. Thank you for joining.
Well, thank you all. I appreciate that. That was excellent, super informative. And I'm always so appreciative after I go through these presentations for people like you who understand the complexities of our energy market and kind of make things run, which is so helpful. We do have one question that came through the chat, Jeffrey, and that is, can you provide more details for how you support regenerative loads?
Okay, finally got it off mute. Yeah, on the systems we have a little magic box. No, it's with the regenerative load, we have our system. We've got it. We're working on the final testing of our system here, where we actually have to burn off the regenerative load with load resistor, and these are the types of systems we're working on right now. So it's basically we're burning off using load resistors. There's a lot of elevator manufacturers, they use drives, but for eco purposes, they are putting in drives without braking resistors. And when you don't have the braking resistors, that's when the regenerative load gets fed back to the line. And in a sense, we're putting in the braking resistors only in the emergency mode type system. All right.
Great, thank you, Jeffrey. Another question just came in. Whose lithium ion batteries are you using?
Well, currently we're working with Saft, and we're also working with another company called PowerSync.
Thank you. All right, well, I don't see any other questions coming through the chat. Give it about another 30 seconds or so. But certainly I want to thank our presenters today. I'd like to thank Scott with eSite, Marianne O'Connor with Staco Energy, and of course, Jeffrey Smith with Staco Energy. We will be sending everyone the link to the recording of this session, so you're welcome to share it with your colleagues. And we'll also be sure to share our speakers' contact information as well in case additional questions come about. Scott, is there anything else you'd like to say before we close it out?
No, thank you very much, Sarah, and everybody, and thank you for joining.
Great. Have a great day, everyone. Thank you. Take care.